Hi class, it's Mrs. Kane and I'm back with your next video. We're going to continue talking about solving exponential equations today. But in day 2, we're going to look at some problems that are a little bit more challenging. So a couple differences. We might have to rewrite both sides of the equation to have the same base. And we might have to use the power property to multiply an exponent by an exponent. So in this first example, what you're going to notice that's different from yesterday, we have 25 to the x plus 1 equals 125. Okay, so we can't use the base 25, okay, because 25 squared is already bigger than 125. So instead, we're going to have to think of a common base that we could use for both sides of this exponential equation. Okay, so we're going to use a base of 5. Okay, so 5 squared. I'm going to replace the 25 with 5 squared. Now, I have a power to a power here. So remember, if you have x to the a to the b, okay, we keep the base the same and we multiply. So this exponent, x plus 1 that was already there, is going to get multiplied by my new exponent. So when I replace 25 with 5 squared, I've now introduced a new exponent. So now I have 5 squared to the x plus 1. So we're going to multiply those powers. Okay, now 125, most of you will recognize that as 5 to the third power. Okay, if you don't recognize that, just use your calculator. 5 squared is 25. If you try 5 cubed, you get 125. Okay, so now we have the same base. Our goal is always to get that same base. Okay, so now we're going to set 2x plus 2, make sure you distribute, equal to 3. Okay, now it's a two-step equation. We're going to subtract 2 from both sides. 2x equals 1, and so x equals 1/2. Okay, so day 2 problems are going to be a little bit more challenging. All right, so the next problem, 4 to the x minus 3 equals 32. Now you might be tempted to use a base of 4, but what happens if we try to use 4? 4 squared is 16, and then 4 to the third is 64. So that's not going to do us any good. Okay, so we got to be a little bit creative here. So what we're going to do, we're going to rewrite both of these sides to have a base of 2. Okay, so we know that 2 squared equals 4. So I'm going to replace the 4 with 2 squared. And now I have a power to a power situation. So I'm going to have to multiply that 2 that I introduced by x minus 3. That was already there. Okay, and then notice I can write 32 as 2 to the 5th power. Okay, and the more problems you do, you'll start to recognize 32, 16 as some expressions that you can write with a base of 2. Okay, so now that I have the same base, I'm going to go ahead and distribute my 2. 2x minus 6 equals 5. And then I'm going to add 6 to both sides. 2x equals 11. Divide by 2, and we get x equals 11 halves. Okay, so notice in these problems, we have to change both of the bases, so we have to be a little bit more creative. All right. A couple more problems here. If you want to try some of these on your own, go ahead, but I'm assuming maybe you want to practice a few more of these with me. All right, so the next problem, we have 25 to the 2x minus 1 equals 5 to the 9x plus 12. Okay, so notice this time we can replace the 25 with 5. Okay, so 25 is 5 squared. Now we have a power to a power situation, so we have to multiply the new exponent 2 by the existing exponent 2x minus 1. Okay, on the right side, we don't have to do anything. We just leave that 5 to the 9x plus 12. Okay, and now that we have the same base, we're going to go ahead and set our exponents equal. I'm going to distribute that 2 to get 4x minus 2 equals 9x plus 12. And then I'm going to subtract 9x from both sides. Negative 5x minus 2 equals 12. And then I'm going to add 2 to both sides. I'm going to move this up real quick. Make some room, sorry about that. So we have negative 5x equals 14. Divide by negative 5, and x equals negative 14/5. Okay, so again, that power to a power property. If you have an exponent and then you have to rewrite the base with a new exponent, you're going to multiply these. So right here, we multiplied the new exponent 2 by the existing exponent 2x minus 1. All right, so the next one, we have 4 to the x equals 8 to the x plus 1. Again, 4 to the first is 4. 4 squared is 16, so 4 is not going to work. So we need to think of something smaller. Okay, so hopefully you recognize that we can rewrite 4 and 8 using a base of 2. So I'm going to replace 4 with 2 squared, and then I'm going to multiply that by the x that's already there. Okay, and then I'm going to replace 8 with 2 to the third, and then I'm going to multiply my new exponent 3 by the existing exponent x plus 1. Now that I have the same base, I'm going to go ahead and set my exponents equal to each other. I'm going to distribute the 3. Okay, in this case, I'm going to subtract 3x from both sides. Negative 1x equals 3. If I divide by negative 1, I get x equals negative 3. Okay. All right, next one. 16 to the x plus 5 equals 64 to the x. Okay, so hopefully you'll recognize that you can write 16 and 64 with a base of 4. Okay, so 16 can be replaced with 4 squared. I need to multiply my new exponent 2 by the x plus 5 that's already there. And then 64 can be replaced with 4 to the third. And then I multiply my new exponent 3 with the x that was already there. Okay, we're always trying to get back to this first setup where we have the same base, and then we can just set the exponents equal to each other. Okay, and then make sure you distribute. 2x plus 10 equals 3x. We're going to subtract 2x from both sides. 10 equals 1x, so x equals 10. All right, and then let's try one more together. This time we have 2 to the 2x minus 5 equals 1/2 to the 3x plus 1. Okay, so in this problem, we actually can write 1/2 with a base of 2. So we need to figure out 2 to what power equals 1/2. Okay, so if we raise 2 to the negative 1 power, we'll get 1 over 2 to the first if we drop it like it's hot. Okay, so we're going to start by rewriting this left side is going to become, the right side is going to become 2 to the negative 1, and then we're going to multiply the negative 1, the new exponent, by the 3x plus 1 that was already there. So we're going to get negative 1 times 3x plus 1. Okay, so now we're going to set 2x minus 5 equal, I'm going to distribute here, equal to negative 3x minus 1. Okay, so now I'm going to add 3x to both sides. And we get 5x minus 5 equals negative 1. And then I'm going to add 5 to both sides. 5x equals 4. Divide both sides by 5, and x equals 4/5. Okay, so that is the end of our lesson on solving exponential equations. I want you to, I'm not going to assign an additional assignment today. I want you to try these 4 problems. Pause the video, try these 4 problems, and then check your answer. And your only homework tonight is going to be to finish your Math Excel, which is due on Wednesday. All right, so hopefully you've tried these, and now you're just checking. I'm going to go through these a little bit quicker than the others because I want you to just kind of check. So I'm going to rewrite this first expression, both sides with a base of 3. So I get 3 squared to the 2x minus 5 equals 3 to the third. So 4x minus 10 equals 3. Add 10 to both sides. 4x equals 13. X equals 13/4. Okay, the next one I'm going to use a base of 6. 6 to the 3x minus 1 equals 6 squared. And then my 2 gets multiplied by the x plus 5 that's already there. So I set 3x minus 1 equal to 2x plus 10. Subtract 2x from both sides. X minus 1 equals 10, and x equals 11. the next one, I have a base of 100 and a base of 1,000. So I'm going to rewrite those with a base of 10. So 10 squared, the 2 gets multiplied by the x plus 5 that's already there. 1,000 can be written as 10 to the third. That gets multiplied by the 2x. So now I can say 2x plus 10 has to equal 6x. Subtract 2x from both sides. 10 equals 4x. Divide by 4. And I get 10 fourths, which is 5 halves. So x equals 5 halves. Okay, the last problem, I'm going to start by rewriting the left side with a base of 25. I'm going to combine these. I'm going to add x plus 2x plus 3. I'm going to leave the right side alone for a minute. Okay, I can write 25 and 125 with a base of 5. So I'm going to write 5 squared, and then I'm going to multiply that by x plus 2x is 3x plus 3. And then I can write 125 as 5 cubed. I'm going to multiply that by the x plus 7 that's already there. So then if I distribute, I get 6x plus 6 equals 3x plus 21. Subtract 3x from both sides. 3x plus 6 equals 21. Subtract 6 from both sides. 3x equals 15. And so x equals 5. I did kind of zip through these last 4 in the hopes that you had tried them, and we're just kind of checking your answers. So hopefully I didn't go too fast. All right, well, I hope that lesson made sense. Feel free to email me with any questions, or if you want me to explain something in more detail, I'd be happy to do so. Hope everyone's doing well. I miss you guys. Talk to you soon.